thank you everybody for joining. My name is Victoria Martinez. I am a technical solutions specialist on our 3D IC solutions. First, we're going to start to talk a little bit about what's driving 3D IC. It's really the shift, right, from monolithic scaling to multi-die architecture. So most in the industry are familiar with the increasing cost and risk of advanced node monolithic designs for low volume applications. This has become prohibitively expensive. This challenge is driving the evolution of multi-die architectures, allowing companies to continue scaling performance while avoiding reticle limits. Chiplets are a prime example of this. By breaking large SoCs into modular reusable blocks, companies can optimize cost, performance, and manufacturability. For higher bandwidth and lower power next-gen applications, memory access and proximity are major bottlenecks, especially in HPC, high-performance compute, and edge computing applications. To address this, we're seeing a growing adoption of HBM and new packaging approaches that bring memory closer to compute. And in parallel, there's an evolution in low-power, short-reach die-to-die interconnect protocols like UCIe, which help improve efficiency and scalability. And then, heterogeneous integration, there are platforms to integrate and mix different process technologies that allow designers to combine advanced logic with legacy IP or specialized accelerators. And these approaches are driving the adoption of interposers and RDL build-up technologies such as fan-out wafer-level packaging to improve connectivity. And this enables greater design flexibility, allowing engineers to optimize trade-offs between cost, performance, and power efficiency. Some of the new design challenges and really our path forward, while heterogeneous integration provides a path forward, it also necessitates new design methodologies and tools that can analyze systems holistically. And this combination of multi-die architectures, right, from chiplet-based designs, HBM, UCIe, and advanced packaging is paving the way for more efficient, scalable, and advanced solutions. So with HI, and you'll hear me use HI and 3D IC a little bit interchangeably, there's an inflection point where this impacts flows and tools, and in some cases, processes and materials. It requires a much more system-centric approach from early planning to final sign-off. This takes various forms, from co-optimization, PPA, cost to cross the chip, the package, the board. Empowering design engineers, this is something that we're seeing in the ADA world and posing this question to the customer. We're starting to see a limited number of analysis experts, SIPI experts, process experts, so their skill set is very valuable. And how do you maximize their usage? And part of this is how do we empower the design engineers to find and fix obvious issues, right? So we're freeing up the experts to focus on a little bit harder problems. How do we look at process-related issues, to metal density and balancing, or how do we look at IR drop issues to enable the people doing the frontline design, without going through a lot of unnecessary iterations. And then, scalability, right? So not only having tool capacity and performance to handle these large designs, and when we talk about large, I'm typically talking about an interposer design, an SoC, an HBM. Some of the bigger designs that we're starting to see right now are upwards of 12 HBM, 4 SoCs, starting to see customers design with CoWoS-R. And having the tool capacity and performance to handle this, but also, innovative features and functions to allow you to deal with the scale of complexity. So one of the examples that you'll see here is starting to incorporate hierarchy and IP reuse as part of the design methodology, something that is pervasive in the silicon design world, but starting to take advantage of that in the packaging design world. And then the other aspect to scalability is managing, all the data, right? So when we start to think about all of the different IP sources that go into a device, and then all of the devices that go into a system, how do we track all of that data? How do we track the lineage of that, provide traceability, right? And having a robust data management system, both at the work and process level, but also at the enterprise level. And last, how do we eliminate the iterations through early insight into things that are typically downstream, right? So how do we eliminate early thermal, early power, early signal integrity, right, from the get-go when we're in the early planning phases, and continue to qualify that throughout the design process. So this shift left type process methodology to really reduce unnecessary iterations. So these are just some of the underlying themes that we're going to be talking about in our solutions today. All right, so when we speak to our customers about an HI solution or a 2.5D 3D IC solution, we do speak to a full end-to-end product offering. The centerpiece of this is our planning cockpit. It's now called Innovator3D IC. This was previously known as XSI. This is where we pull all of the data together and aggregate the system. And the system being the various side data, interposer, bridge, package, and we bring that together into one environment. And within that environment to our floor planning, our net lists, and logic authoring, being able to launch into predictive modeling. And we'll expand on this in a little bit more detail. We do also talk about having physical layout capability for the package or interposer substrates. We're in Expedition being able to do 3D SOIC with our Prezi tools. We have a robust physical verification options using Calibre and Calibre 3D Stack. We got hyperlinks, DRC, I mentioned a little bit earlier, talking about user personas. We have a full suite of mechanical design and simulation tools, right? This would be our Siemens NXCAD tool, as well as our SimCenter portfolio that's targeted more to a thermal mechanical engineer. And the idea here is to allow us to look at modeling temp cycling, warpage analysis of substrates, lead and bump deprivation, looking at some of the mechanical stressors of our design. And then looking over at the other side of this graphic, on the right-hand side, there's a full suite of multi-physics modeling capability, both at the die and package level. And we have our system-level SIPI tools, like the Hyperlinks portfolio, like our system-level thermal with FlowTherm, as well as our DFT tools like Tessin. And as well, the design for reliability with our PERC tools, and that would be looking at tools like ESC resiliency and EMIR type characteristics. And all of this is supported by a very robust data management solution at the enterprise level. And this is something known as Teamcenter, which is a PLM tool. And EDM, or Engineering Data Management, which is our work in process data management, and that integrates with the tools that we're going to be talking about here. So when we talk to our customers, we do talk about our solution, and here we offer an end-to-end aspect of this. We do also mention the ability to plug and play into third-party vendors as well. All right, so i3D, or Innovator3D IC, you'll hear me refer that to as i3D, is a new tool that we released in September of last year. And this is really to meet the demands of the semiconductor industry. We look at what the foundries are doing, what the OSATs are doing, as far as technology evolution, and being able to have a platform really targeting 2.5D and 3D IC environment, and being able to have the next generation chiplet environment. Having something serve as a cockpit or foundation for all of the Siemens solution. So what is it? It's the evolution of XSI, or Expedition Substrate Integrator, as I mentioned earlier, something that has been available for quite some time. And that was our starting point, right? We built Innovator3D IC on brand new architecture, and it has a brand new AI user-driven interface. It's available on both Windows and Linux. This was also done as a competitive response that is designated 3D IC, which is pretty significant for us. So i3D is our planning cockpit, right? It includes all of the floor planning and net list offering and logic matching capabilities that XSI had included. And it has some new features as well. It also serves as an environment where we can manage the entire connectivity. So one of the challenges with these types of systems, let's say we're dealing with an SoC or a couple SoCs with some HBM on a silicon interposer that's sitting on an organic substrate, is how do you manage that logic? How do you author that logic in a typical system? You may have a schematic or an RTL netlist, and all of those may be input options for an HI system, but what environment is the keeper of that logic? And surprisingly, most customers will come back to us to tell us that they're using Excel. They're using some version of a spreadsheet managing across multiple different teams, and that process is very disjointed. One of the things that i3D does is it does provide the opportunity to use it as the logic management tool for the entire system, from early planning through final LVS of the entire system. We have a tool that's called Calibre 3D Stack. It allows us to do 3D LVS, and one of the key inputs to that is the source system netlist. So the question becomes, where does that come from? And in this case, it's coming from i3D. You can also use this to do some of the die-to-die chiplet interface planning, figuring out route feasibility, route resource planning, and this becomes a platform to launch into our predictive modeling tools and being able to go into domain-specific or application-specific areas. So, for example, once we have defined the interposer substrate or the package substrate, we can package that up and send that up to the layout tool. This could be Expedition Package Designer, this could be Cadence APD, or some other layout tool. Likewise, we can launch into our verification tools or our simulation tools. The idea being that we have all of the data representing the full system, and it's just a matter of how we partition that data out and do the setup to launch into our prospective modeling tools. And you can find a couple examples of this with our thermal technology and our 3D verification technology. One of the biggest challenges in 3D IC design today is that we are dealing with two different worlds that are colliding. We have the IC design world and the packaging world. And each group, right, the IC designers, packaging engineers, they view the system through a little bit of a different lens, and leading to different just design flows, sometimes conflicting solutions. So this disconnect creates inefficiencies, right, miscommunications, workflow bottlenecks, and that slows down the entire design process. A major pain point for maybe many of you, right, particularly those focused on analysis rather than package design, is that you may receive GDS data from the IC team and need to integrate it with the package substrate data. This is not a straightforward process. Merging these data sets to perform a complete analysis of the interposer and substrate is time-consuming, it's complex, and it can be extremely frustrating. Many companies attempt to string together internal solutions, but these often lack consistency and efficiency. i3D acts as a unified platform that can bring together these two different worlds, helping users seamlessly integrate IC and packaging data into a cohesive design and analysis workflow. It enables a combination of GDS data and design level information, or as you can see here, right, like chiplet data, substrate data, our physical verification tools, chip level and package level extraction tools. So with i3D, you're no longer forced to manually stitch together fragmented workflows or struggle with miscommunication. Instead, everything is streamlined into a single efficient environment. i3D is not just for package designers, it's specifically designed to support, also analysis teams, right, giving them tools to effortlessly merge IC and package data, run full system verification and extraction in a single workflow, and gain early predictive insights to prevent some downstream issues. So in conclusion, right, 3D IC requires a shift in how we think about design integration. i3D does bridge the gap between IC packaging, providing a unified solution that eliminates workflow, fragmentation, miscommunication. And for analysis teams, this means faster, more reliable system-level insights without the frustration of merging incompatible data sets manually. All right, and that's it. Thank you.